we record. Okay. So today what we'll talk about, a little bit about Amazon Web Services, some of their core products there. In case you don't know, Amazon Web Services is their public cloud offerings. And we'll talk a little bit, a little back in history, circa 2010, why businesses needed the cloud. And then eventually over the course of the next couple sessions, we'll talk about more about cloud services generally. All right. So in case anybody didn't know, Amazon has the world's largest cloud operation. And that's measured in terms of sales. So it's entirely possible that Google's internal cloud, right, what they use for Google's own stuff, might be bigger than Amazon's, or Facebook's cloud that Facebook stores their own stuff on might be bigger. But those products, you know, Google's internal system isn't sold to Google. Facebook's internal system, you know, Facebook is provided as a free service anyway. So there's no charging built into that model, right? But as far as people who are showing up and paying to use cloud, Amazon's the biggest one. And if you look at the numbers, it has about 34%, which is a bit more than the next two. Anybody know who Azure's owned by? Anybody know that one? Yeah, go ahead, shout it out.
Microsoft.
Yeah, Microsoft, very good. Okay, so Microsoft Azure is one, Amazon has AWS. Of course, Google has Google Cloud. Alibaba Cloud is owned by Alibaba. You probably figured that one out. IBM is owned by IBM, and so on. Okay, but Amazon is the big one. And something of the reputation of the 800-pound gorilla of cloud. Anybody know the joke about the 800-pound gorilla? Nobody knew this morning either. These are strange times. Where does an 800-pound gorilla sleep? In a really big bed. No. The correct answer is anywhere it wants to, right? Because it's an 800-pound gorilla. What are you going to do? Tell it no? Right. So that's what we mean when we say the 800-pound gorilla, which means Amazon is big. They get to pick whatever opportunities they want to chase after. They pretty much get them. Its competitors get to, you know, pick over what Amazon leaves behind, is basically the state of the world. Okay. Now, their annual cloud revenues, about 70 billion. None of these numbers are going to be on the exam, by the way. I'm not going to ask you, what were Amazon's cloud revenues in 2021, right? That's the point I want to give you, is that it is big. All by itself, Amazon's cloud services would be one of the biggest companies in the United States, right? But, you know, cloud is actually a fairly small part of Amazon's revenues. Anyway, has a 30% market share. It was similar a few years ago in terms of market share, but its revenues are up from 25 billion in 2018. So just in like 4 years, because that's a 2022 number, you know, they've almost tripled. So cloud has been growing quite a bit. It's bound to taper off, but, you know, it's having some remarkable growth right now. Now, Amazon has about 34% market share. Next biggest three, you see in the previous slide, have about 36%. The next biggest 10 altogether have about 20%. So cloud services very definitely dominated by a fairly small cluster of services, right? What you might call an oligopoly. Not quite a monopoly, but there's only a few big players. If you're interested in learning more about Amazon Web Services, I have a helpful link right there. You can go check it out, aws@amazon.com. Interesting thing about cloud, right? So when Amazon started in 1994, nobody was thinking about cloud. Cloud wasn't really a thing yet, all right? And it wasn't going to become a thing for about 15 years. Now, there was some stuff out there, what might be called grid computing, or like renting out shares of a supercomputer. Basically, if you had to do some really complicated number crunching or, you know, algorithmic process, whatever, something that you didn't have the hardware to do under your own roof, you could send that problem out, in some sense, to another facility, and they would process it for you and then send you back the results, right? It's the same kind of thing that the science guys use. You know, they have their supercomputers. They like gather all sorts of space data from telescopes, and then they send it to some supercomputer to get processed, and they get the results back. So that was kind of like cloud, but it wasn't the same way where, you know, you just go to a portal and you show up and you use it. It's much more technical, right? It's not for the ordinary user to use. Now, 2000 though, the way cloud happened Amazon was building lots of tools to help retailers sell things through Amazon. Specifically, they were building interfaces. So anytime a retailer wanted to upload a batch of data, like a product description and pictures and stuff like that, they had to go through some interface into Amazon's system, right? They had to make sure that the data was in some sense formatted correctly so Amazon could construct a web page out of it. Now, Amazon's engineers, being either overworked or lazy or cost conscious, at some point they said, wow, this is really a pain in the ass. We're designing all these custom interfaces for all sorts of different people trying to upload different kinds of data. And wouldn't it be great if we could manage with a much smaller set of interfaces, right? If we set up an interface that could handle many different kinds of data. Well, that was essentially the core of what started out, what eventually became cloud for Amazon. Because, what people would eventually do is, rather than filling out a form exactly with the exact things that needed to go into a perfectly constructed web page, eventually the retailers were able to upload like XML files that would have a tag for here's the product name, here's the product description, here's another tag for an image, here's another tag for, who the shipper is, who the seller is, stuff like that. And Amazon could take, some of those tags and use them to construct a page. And the ones that it didn't need or didn't want, it just wouldn't bother with. And that's sort of the same thing that leads to cloud, right? Because Amazon, once they're at some point they realize, it doesn't matter what kind of data people are sending us. The interface, that process parses through all the code, all the data that they're sending us and puts it into the correct format that it needs to be for something. And if we can do that with any kind of retail product, we could do it with basically any kind of file, any kind of data batch, just upload it and process it, and boom, that's basically cloud. So if you are interested in a more detailed description of all that, there's a nice little article here. So if you're thinking about being an IDS major or you're just generally interested in cloud, by all means, check out that link. It's pretty recent, 2016, although it talks from older stuff. And, you'll understand what cloud is kind of about. You should know enough at this point, if you've been paying attention in class, you should know enough that you can understand most of what they're talking about in that article. Shouldn't baffle you too much. It's readable. All right. There's a couple services that Amazon sells that we'll discuss. The first one is Amazon Simple Storage, or S3. S3 is a massive key value store. Anybody remember what a key value store is? Anybody know, but they're too scared to say anything? Nobody? We talked about it towards the end of one of the Facebook lectures. Remember, I think the end of the first Facebook lecture, maybe the second. A little fuzzy. No? Nobody? What's the difference between a key value store and an ordinary relational database? It's not a good sign. Are you all guys just cramming and not trying to remember anything for any point in the future? Is that what's going on? All right. Well, I'll tell you then. So a key value store is basically a kind of database where every record can have a completely different format from any other record. So in a sense, each record becomes like its own database with its own unique, set of tables and fields and all that. And this makes sense for what we'll talk about for how simple storage is used. So first of all, each key value record, right, is estimated, it has a max size of like 5 terabytes, but most of them are a lot smaller than that. But Amazon, last I looked it up about a year ago, said it had about 5 trillion objects. They might have more now, but it doesn't matter if the objects are small, because 5 trillion of them is going to be a whole lot of data, right? Think about it. If we're talking 1 terabyte hard drives, okay, and that's 5 trillion, we have 10, let's say the average size is 10 megabytes. So that's 10 million times 5 trillion, right? They would need what? 500? They need 500 million hard drives to store all that data, right? Ordinary terabyte hard, if my math is correct. Maybe only 50 million. They need 50 million hard drives to store that much data, which is a lot of storage, right? And on top of that, they need backups. And that's just for this one system, right? That's not for any of Amazon's own stuff. S3 is all basically other businesses storing data. So when you're dealing with that many disks, it's vitally important to pack the data in tight, right? When you have a relational database, remember every record uses the same fields, and the field is formatted for the entire table. So for example, if you have a field last name that could be like 30 characters long, there's going to be 30 bytes of space reserved for that field in every record. But most last names aren't anything like 30 letters long, right? Maybe they're like 10 letters long, maybe 6 on average. So you're going to have a lot of dead space in that database. Well, when you're talking already, even if it's all packed in, if you're talking that it's going to be like millions and millions of hard drives, if you have empty wasted space, yeah, storage isn't that expensive, but it's going to add up at that scale. So Amazon wants to pack them in tight. That's first thing. Other stuff, accessibility. So number one, it's a fairly cheap service. That's nice. It's reliable. That's nice. I mean, you would want that in any, I guess, most services. But accessibility is a big thing. So imagine if you're a business that uploads a bunch of data to Amazon, and the end of every day you upload a new batch of data to get integrated with the data you already have, so you can do some kind of analytics on it, right? Like supply chain tracking or order fulfillment issues. If you're doing shipment tracking, stuff like that, whatever. You need to have all of that data be accessible. It needs to you always got to be able to get to it. Now, this was one of the big problems early on, as far as why businesses didn't go into the cloud. We'll talk about that eventually, but imagine if a business has uploaded a terabyte of data, okay? And they want to get it back because they want to do some analytics on it. Anybody ever download a 1 gigabyte file? Of course you have. Somebody has. About how long does that take? It depends on your internet connection. I would guess closer to 1, but sure, maybe it takes a few minutes. How many gigabytes are in a terabyte? 1,000. Just 1,000. 1,000 gigabytes in 1 terabyte. So if downloading 1 gigabyte takes, say, a couple minutes, then downloading 1,000 gigabytes is going to take like 2,000 minutes, which is a very long time. All right, 2,000 minutes is almost 1 complete day. So that would be basically your boss says, hey, can you download a batch of data? We want to run some, I got some questions I want to look into. And you're like, yep, I just clicked download and I'll come back tomorrow morning and we should have it all, right? That kind of sucks. So the data's got to be very accessible for businesses. In particular, what Amazon did to deal with that has built-in analytics capabilities. So the business who's uploaded these batches of data, they can run queries on it without actually having to access the data, without actually having to pull all the data from the website. Because maybe you do have some reason where you need your complete set of data. I don't know why. It's going to take a while over a standard internet connection. Not much to be done about that if you have a lot of data. But if you just want to run queries on it, Amazon can help you out with that, right? And then you won't have to actually download anything. You just send the query to Amazon, they'll crunch the numbers, and they'll send you back the results. So that's Amazon Simple Storage. What it is where businesses want to upload big batches of data and perhaps do some analytics on it, okay? Run some queries on it. Another major Amazon product is Amazon's Elastic Cloud. Many people would consider this to be the core element of Amazon's cloud computing service. What it is if a business wants to run applications in the cloud, right, rather than on their own premises, then they rent what are called virtual servers. So rather than reserving a specific number of specific pieces of hardware, what businesses do is they say, I would like, I'm going to run this application, and whatever hardware capabilities are needed at any given moment, whether the system is very busy or not so busy, just build me for that, right? Because the hope is that if the system is busy, it means you're making more sales and you don't really have to worry about the cloud expenses because, your sales should cover that. So at the end of the day, Amazon tabulates how much work your application required and whatever whatever measures of system capacity, whether it's memory or network traffic or CPU cycles, however it's calculating that, whatever share of the system you're using, Amazon is going to equate that to some number of server equivalents, and they're going to charge you for that. And the term that Amazon actually uses is elastic compute units. But the idea is still the same, right? They track how much you're using over the course of the day. They equate it to some, number of equivalent of servers, and then they charge you for that. So EC2, again, businesses are typically deploying applications like maybe big data analysis or transaction processing, but it could be anything, any application that they want to do, they can post up there. And the nice thing about EC2, it provides backup capacity, right? So if the system is not very busy most of the time, then your base rate for how much you're getting charged is not going to be that high because you're not using that much in terms of system resources. But if your system does get busy for some reason, then Amazon is there to help you out with that. Okay, it's a lot cheaper than having all the hardware you need to cover your worst case of demand all the time. We'll talk about that eventually too. All right, I'm going to draw a cloud. Okay, we're going to draw some clouds here. Bum, bum, bum. All right, so you get a phone. This is your little smartphone. I'm not going to say what brand it is, but it looks like maybe like an Apple. I don't know. Okay, that's you. Your phone. Ordinary user. Okay, what's that? Now, we got to draw some cloud. I'll use light gray. Okay, so our cloud system, woo, cloud. Okay, that's our cloud. Don't laugh, that's what it looks like. And this is cloud. Ah. This is harder than it looks. Okay, so this is the cloud. I'm going to draw a server here. And it's not going to be the best looking server, but you're going to look at that and say, okay, yeah, sure, I'll believe that's a server. Okay, so this is our server, and some user is going to show up. And there's going to be a few servers they could connect to. Okay, so there's going to be an interface. There's going to be an interface that they go through. And mark that interface. So what happens is any user shows up, connects to the interface, right? They go to aws.amazon.com, for example. Amazon will automatically connect them to one of these servers. Okay, so I'm going to draw some arrows. And these servers, they may very well need some data to do whatever it is they do. So I'm going to draw a couple database machines here. I'll call them DB1 and DB2. And in a real large-scale cloud system, of course, there would be many more machines, but I'm not going to draw them all. So any one of these, you're going to get connected to some server, and that server will be able to connect to any of the databases that are there. Okay, so from the point of view of the user, it's just, I go to this interface, and the rest of the work is done for me. It automatically connects me to where I need to be, which is great, right? Users don't want to know about that stuff. So, in a cloud instance, when we talk about instances, basically like one part of the cloud system, we generally mean like a server cluster. So a set of servers. Now what happens typically, it's easier to switch people within one server cluster than to switch them to another server cluster. So for example, suppose you're using some application on this top server in the stack, and the server has some failure and it needs to reset. Well, they can very quickly switch you over to another server that has the same connection to your data and is running the same applications, and it'll be there and ready for you, right? And it's very quick to switch you over like that. If necessary, of course, they could switch you over to a different cluster, but that's going to be a little bit more time, right? But yeah, so generally, every server cluster will typically have all the applications that a user is likely to need. So any user who shows up, they're going to maybe look at your profile, and they're going to say, oh, you use these applications. It makes sense to send you to this particular server cluster, which is running all those applications, right? And of course, without getting deep into the details of how cloud systems decide and how they track and all that, just within your cluster, there's going to be each different server is probably going to be running one separate application. And so, if you have more servers, you're probably going to be able to run more applications. That's all. And there can be variations in terms of operating systems. You might have different servers within a cluster running different operating systems as well. So cloud, in that sense, is very much like a utility company for providing electrical power. So, surprise question. Does anybody know where electricity comes from in any reasonable level of detail? So I go and plug in something into that wall outlet over there. There's going to be electricity. How does electricity get there? Yes, but how does it get there? Where does it come from? How is electricity made? That's a big part of it. How do they get the magnet to spin fast without using electricity? Gas. How do they use gas? Yeah, but how? I mean, you could set some stuff on fire, sure. How's that going to make the magnet spin around? What's that?
Kinetic energy.
Yes, kinetic energy can make something spin, but how is the power in that burning gas converted to kinetic energy to spin the magnet? Combustion just means burning, so steam is part of it. Yes. All right, so we have eventually stumbled. See, now I actually, I was a Navy nuke for a few years, and this is what I did back in the 90s. So we had a nuclear plant, and basically the rock gets hot and turns water hot, and that water turns into steam, which is used to make a turbine spin around. And just like you said, that makes the magnets inside go spin, spin, and it creates an electron pump that sends out the electrons. Okay. Same thing in a conventional power plant. They probably burn coal. Coal makes some water, turns that water, makes some water into steam. Steam makes the turbine go roundy round, and then again, pumps electrons out to everywhere that needs them. Now, you don't need to know any of that to use the outlet, do you? You just need to have a plug and say, I know that that outlet is live. I can stick the plug in the wall, and boom, I get electricity, right? Isn't that great? Isn't it nice to be able to get electricity without knowing a damn thing about power production? Yes, that is wonderful, right? It's like if you couldn't use a microwave unless you knew in detail all the physics of microwave ovens, right? And I don't know much about that, so I'm not your guy to talk to. But same thing with cloud. You don't need to know anything on the other side of the interface. You don't need to know which machines your data is on, how the servers are set up, what operating system they're using. You just know, I go to the interface, everything I need will be right there, right? And you also know on top of that, it's going to have backup and recovery services that, again, you don't have to manually deal with. Makes life very easy, okay? For people on the outside. Cloud system, of course, has to do that. All right. Questions on any of that? Would anyone like to know more? All right. Well, we'll talk a little bit more. Then I have a little bit more to say today. So, cloud didn't actually start to catch on until about 2010. And a big reason for that, well, the way businesses had always done it is any business large enough to need computing power had the computers under its own roof. Okay, and they felt that was a good way to do it because that kept your data safe, your data was internal, kept your program safe, you wrote them, you didn't have to worry about somebody else messing them up. Okay, businesses like to maintain that kind of control over their information technology. And, as well into the 90s, that was a pretty good model. Even well into the aughts for most businesses, that was a pretty good, the aughts, the first decade of the 2000s. Yeah, for many businesses, that was still a pretty good model. But big reasons, number one, business as usual. If everybody else is doing it, there's no reason for one business, to go out on a limb and try something terribly new, right? This is the way of the world. In particular, think about how initiatives happen within a business, right? Basically, somebody has to be there pushing for it, saying, I want this thing to happen, right? And if you've ever heard the saying, success has many parents, but failure is an orphan, yeah, that's the thing, right? So go into cloud, there's a lot of actual risks in that, right? Basically, for a variety of reasons, it might not work as well as you hoped it would. Maybe there could be some massive data leakage. Maybe the cloud system would actually lose your data. They'd fail to back it up properly, right? Maybe they'd switch out some stuff and they'd give you the wrong data. Maybe it would just be really expensive, way more expensive than you thought, and not save you much money, right? Anything like that, if there's some guy pushing very strongly for cloud to be the thing, and it ends up not going well, that's going to be his head on the spike, right? He doesn't want that. So unless there's a really compelling reason to do it, businesses are just kind of just going to keep doing what they're doing. And there were valid concerns about these things. So number one, security perceptions, right? There weren't any cloud systems out there with a whole lot of track history about serving customers well. So you didn't know. The businesses knew, well, our data is fairly safe under our roof. Why would we give it to somebody else? And businesses also wanted to maintain control over their system designs. So one of the problems that you would often see when businesses did send their data or their applications to a cloud is they'd have some system that would work great under their own roof because of the way it was designed. And it wouldn't work so well in the way it was in the cloud because it could get implemented in a different way. So one of the things we've talked about with large databases, they can work pretty fast as long as the data is all stored in RAM, right? So if you have one big database system and it's all running on the same piece of hardware and the tables are all stored in RAM on that machine, even if the code for it is not particularly efficient and the system isn't set up to be particularly efficient, the fact that it's all in RAM is going to make it run really fast. But maybe when you send it to the cloud breaks up that table and puts it on those two tables and puts them on different machines. And then any interactions that used to be super fast because it's in the same hardware under your roof, it's implemented differently on cloud, and suddenly queries take a really, really, really long time to happen. It was a fairly common problem back in the day. And last, accessibility, right? So again, we talked a little bit just a minute ago about how long it would take to download a terabyte. Think like circa 1998, okay? 1998, most people who had internet had some shitty dial-up connection with like a 33 kilobit per second rate, or maybe 56 if they were fast. The top of the line at that time was probably the T1 line, the top of the line standard probably was the T1 line, which could get an amazing 1 megabit per second, that was as good as it was going to get. And if you were a business that had a gigabyte of data in the cloud, that was going to take you 8,000 seconds, more or less, to pull, right? Because 8 bits to a byte, 8,000 or 1,000 megabytes to a gigabyte, it's going to take you like 8,000. How long is 8,000 seconds, ballpark? About how long?
Like
how long in hours?
Like 1.6 hours.
A little bit more. Divide by 3,600, right? So a little over 2. Something like, 2 hours, close to 2.25 hours. So that's a long time, right? And a lot of businesses probably have a lot more than a gigabyte of data. Imagine if a business has 100 gigabytes of data. It's going to take 200 hours to pull that batch of data down from the cloud, right? That's probably not acceptable. Just saying. So accessibility was a real concern, but data kept on growing. Now, excuse me. So growth is a nice problem to have, right? If you got to pick the problem of growth over atrophy, right, over shrinking, growth is probably the one you want to pick. But if you get bigger, you're going to have more data, and more data brings problems, right? All these scalability problems we've been talking about. So number one, any kind of analysis you're doing, right? If you want to run a query on your database or crunch a whole bunch of numbers using your entire database, if you have more data, it's going to take longer to do that. Okay. Next thing, storage versus accessibility, right? So it's fairly easy to store data if you don't care too much where it goes. But if you have to organize that data in order to retrieve certain bits of data quickly, that's going to be extra work. So the difference is, right? Imagine you have a garage and you just throw stuff in there, right? You can pack that garage pretty tight full of stuff. But when the time comes that you want to find a particular thing, that might be a challenge, right? Same thing, if you have a closet, it's easy to pack stuff into the closet. Try to find it later, good luck, right? So same kind of thing, making data accessible requires more organization, more work, special kinds of hardware. So again, like back in the day, circa 1990, tape drives were really cheap for the amount of storage they provided. But if you used a tape drive to store all your data, it would take a really long time to recover it because tape drives were slow. Anyway, and all the other things you got to do with your databases, like making backups, like making copies at different data centers, moving your data around within your systems, doing consistency checks to make sure that one copy of the data is the same as the other copy. All of those kind of standard activities are going to be a lot more work if you have a lot more data. So if you're interested, you want a little, back in time through the Wayback Machine, a couple articles there from circa 2010 where they interviewed a bunch of IT people, and they all said, yeah, data growth is like one of our biggest challenge, if not the biggest challenge. So, excuse me. So I'm going to take a minute to talk about that. Then I guess we'll be done. Unless people have more to say. All right. So, suppose it's, what year is it? It's 2000. And your business usually only requires one server, but sometimes it's busy and needs 10. So you have 10. And those servers cost about 10K each. So in a sense, you are wasting how much? 90,000. Very good. 90,000 every year. But that's tolerable and an expected cost of doing business, right? If you're a big company, close to like $1 billion in sales, 90K, that's like a rounding error. It's like, we'd like that we didn't have to pay it, but whatever. It is what it is, right? We got to be online. Okay? But it's now, I'm just going to edit here. But it's now 2010, and your business has grown and usually requires, what number shall I do? Usually only requires 20 servers. But sometimes it's busy. It needs 200. So you have 200. Okay? And those servers, they're more powerful, but they still cost the same. They still cost about 10 grand each, so fine. So in a sense, how much are you wasting every year? That's okay, I won't make you do the math. You're wasting about $1.8 million every year. But that's tolerable, barely, and it's an expected cost of doing business. So what are you going to do, right? And this is 2010. This is when businesses are starting to look around and say, ooh, man, this is a problem. We got to, how can we get out of this hole? Okay. But it's now, right? We'll do this. It's now 2020. And your business has grown. And let's see, what number shall I use? Let's say your business usually only requires 400 servers, but sometimes it's busy and needs 4,000. So you have 4,000. And those servers still cost about 10 grand each. So in a sense, how much are you wasting? 360 times, or 3,600 times 10,000. All right, so if my math is correct, and sometimes it is and sometimes it isn't, I'm just going to go in and do the calculator because I don't trust my brain anymore. Calculator, there we go. All right, 3,600 times 10,000. 360 million, right? Is that 36 million? Is that all? 3,600 times 10,000? I guess so. Okay. 36. No, see, I shouldn't trust my brain anymore. And that's a problem, right? And that's a problem because you can see by 2030, maybe you'll be wasting $1 billion every year. Okay? So what happened right around this time, right, 2010, this is when businesses start very seriously considering going to cloud, right? And some actually do. Okay, this one, if you haven't switched over to cloud by now, you are in trouble if you are even still competitive in your industry, right? Because as we'll talk, aside from just saving costs, cloud does provide some other benefits, right? It's the same as outsourcing anything else. Most of these businesses, they don't really want to be in the IT industry. Cloud businesses, they do want to be in the IT industry. That's their thing. So you let somebody who does a better job of all this stuff take over for you. They can provide better service at a lower cost. A lot of ways make your life easier. Okay? So that's a good break point. We'll come back on Friday. Between now and Friday, I will surely talk about, on Friday, I'll probably post the FAQ and the TOI for the exam and take a minute to talk about that on Friday. All right. See you next time. Bye, everybody.